Hello, this is Dr. VC Sontake and I am going to take the course Heat Transfer. Objectives of this video lecture are to derive the expression of log mean temperature difference LMTD for cross flow or multipass heat exchanger and to introduce correction factor for cross flow or multipass heat exchanger. Log mean temperature difference for cross flow or multipass heat exchanger. The expression for log mean temperature difference in the form of delta Tm is equal to delta To minus delta Ti over log of delta To over delta Ti, which can also be written as delta Ti minus delta To over log of delta Ti by delta To. This expression was developed earlier and is related with parallel flow and counter flow heat exchangers both. Basically, it is a general expression applicable for parallel flow and counter flow heat exchangers. In this expression, delta Ti is temperature difference between the hot and cold fluids at the inlet of heat exchanger, that is area is 0. This delta Ti can be given as Thi minus Tci for parallel flow heat exchanger, where H represents hot fluid, C represents cold fluid, I represents inlet, and equal to Thi minus Tco for parallel flow heat exchanger. Also, delta To represents temperature difference between the hot and cold fluids at the outlet of the heat exchanger, that is AO is equal to entire heat exchanger area. This delta To can be given as Thi minus Tco for parallel flow heat exchanger and Tho minus Tci for counter flow heat exchanger. The figure shows the temperature variation of hot and cold fluid flowing across the length of the heat exchanger, particularly for cross flow heat exchanger. Here, temperature of the cold fluid is varying from Tci to Tco and temperature of the hot fluid is varying from Thi to Tho, and both the fluids are flowing perpendicular with respect to each other. Now, in both parallel flow and counter flow heat exchangers, temperatures on both sides, that is inlet and outlet of heat exchanger, vary along the length of the heat exchanger and are functions of single variable, say x. Means, in case of parallel flow or counter flow heat exchanger, temperature is varying only along the single length of the heat exchanger. It is not varying in the direction perpendicular to the single direction. However, this is not the case for cross flow heat exchanger as shown in figure, where temperatures of both hot and cold fluids are varying along the x and y direction both. So from figure, it is quite obvious temperature of hot and cold fluid in case of cross flow heat exchanger are now function of x and y, and exit temperature profiles are not uniform. So in such case, determination of log mean temperature difference involves double integration and becomes complicated. So since temperatures are varying in x and y direction, to get the variation of temperature in x and y direction, we need to differentiate it twice, and that makes the derivation quite involved and complicated. However, in case of cross-flow and multi-pass heat exchangers, the appropriate mean temperature difference can be obtained by introducing a correction factor capital F to the log mean temperature difference for counterflow arrangement with the same hot and cold fluid temperatures. Considering this concept of correction factor applied to the expression for LMTD for counterflow avoids the complicated derivation in case of cross-flow heat exchanger. So, in case of cross-flow heat or multi-pass heat exchanger, log mean temperature delta Tm will be equal to F into log mean temperature difference for counterflow. So, this expression forms the basis of log mean temperature difference for cross-flow or multi-pass heat exchanger. In this expression, F is the correction factor and it depends on the geometry of the heat exchanger and the inlet and outlet temperatures of the hot and cold fluid streams. The value of this correction factor F varies from unity to 0. If the value of correction factor F is equal to 1, it is for counterflow heat exchangers. And if the value of F is less than 1, it is for cross-flow and multipass arrangement for cell and tube type heat exchangers. The value of the correction factor F represents the degree of departure of true mean temperature difference from the LMTD for a counterflow heat exchanger. The value of F actually denotes how far the log mean temperature difference of cross flow is deviating from the LMTD for counterflow heat exchanger. Now the correction factor for cross flow or multipass heat exchangers have been published in the form of charts by Bowman, Mueller and Nagle and by TEMA. The long form of TEMA is Tubular Exchanger Manufacturers Association. Hence, considering the log mean temperature difference for cross flow can be obtained by introducing the correction factor multiplied by LMTD for counterflow. Hence, the total heat transfer rate in cross flow or multipass heat exchanger is expressed as Q is equal to U into A into delta Tm for cross flow or multipass, which can be further written as F into U into A into delta Tm for counterflow. In this expression, U is overall heat transfer coefficient and A is surface area available for heat transfer in heat exchanger. And delta Tm is log mean temperature difference for counterflow heat exchanger between the same hot and cold fluids. The correction factor F for common cross flow and cell and tube heat exchanger configuration is given in terms of two temperature ratios, capital P and R, those that can be defined as follows. So the expression for P, it is also called as temperature ratio or effectiveness ratio, is equal to small t2 minus small t1 over capital T1 minus small t1. And capital R is also called as capacity ratio, which can be given as product of m dot Cp tube side and product of m dot Cp into cell side, where m dot is the mass flow rate and Cp is the specific heat. After simplification, the expression for capital R becomes capital T2 minus capital T1 over small t1 minus small t2. This can be considered as now in above two expressions. Capital T represents the temperature of fluid flowing through the cell side, and small t represents the temperature of fluid flowing through tube side. So T represents fluid temperature in the cell side and small t represents temperature of the fluid in the tube side. And subscripts 1 and 2 represents inlet and outlet of heat exchangers respectively. Now some of the different types of cross flow or multi-pass heat exchangers are when both the fluids are unmixed, when both the fluids mixed, when one fluid is mixed and another is unmixed, one cell and two tube passes and multiple of 2, and 2 cell passes and multiple tube passes. So all these are possible types of cross flow or multi-pass heat exchangers. Now the value of correction factor F can be found out in the form of charts, and these charts are varying from type to type of cross flow or multi-pass heat exchanger. So the chart shown in figure is for one cell pass and 2, 4, 6 or any multiple of 2 tube passes. So here as you can see there is a single cell and the tubes can be 2, 4, 6, 8 or any multiple passes. Capital T represents the temperature of the fluid on the cell side and small t represents the temperature of the fluid in the tube side. 1 represents inlet and 2 represents outlet. So for given value of P, I can find out the value of correction factor F. Here on x-axis the value of P are varying from 0 to 0.9 and the value of correction factor is varying from 0.5 to 1. The value of R are shown in the form of curved lines, pink curved lines, and its value is varying from 0.2 to 4. The chart shown in figure is applicable for 2 cell passes and 4, 8, 12 or multiple passes of tube. So for given value of P and capital R, we can find out the value of F for this type of multi-pass heat exchangers. The chart shown in figure is applicable for single pass cross flow with both fluids unmixed. Here both the fluids are flowing through the separate tube and they are not mixing. So for given value of P and R, we can find out the value of correction factor F. And the last chart shown in the figure is for single pass cross flow with one fluid mixed and other unmixed. So one of the fluid is flowing through the tube, it is not mixing, and second fluid is flowing through this and it is mixing. So for given value of P and capital R, we can find out the value of F. So in this way, by referring these charts for a particular type of cross flow or multi-pass heat exchanger, we can find out the value of F, and if this value of correction factor F is multiplied with LMTD for counterflow heat exchanger, it will give us the value of LMTD for cross flow or multipass heat exchanger. Apart from this chart, some of the formulae which may be helpful to solve or analyze the cross flow heat exchangers are listed. So let the capital L represents length of the tube in a single pass. P represents number of passes. Capital N suffix P represents number of tubes in each pass. Capital N represent total number of tubes required in a particular heat exchanger. So it will be product of passes into number of tubes, that is P into NP. Let V represents velocity of fluid flowing through the tube. Small d represents diameter of the tube. M dot tube represents mass flow rate of fluid through one of the tube, and it is given by pi by 4 d square into V into rho. So total mass flow rate of fluid passing through each pass will be equal to total mass flow rate, and it will be given by mass flow rate through the one tube into number of tubes in each pass. So total mass flow rate of fluid passing through the heat exchanger will be equal to m dot tube into NP. So it is given by m dot is equal to pi by 4 d square into V into rho into NP. Hence, for multipass heat exchanger, total heat transfer surface area of heat exchanger A suffix T will be equal to area or surface area of one of the tube multiplied by total number of tubes, which can also be given by AT is equal to pi dl into N, and it is further extended to AT is equal to pi dl into P into NP. So this is the area of either cross flow or multipass heat exchanger in terms of length of the heat exchanger, number of passes, and number of tubes in each pass. So learning outcome of this video: after watching this video, the learner will be able to derive the expression of LMTD for cross flow or multipass heat exchanger, and will be able to introduce correction factor for cross flow or multipass heat exchanger. So with this, I come to an end of this video lecture. Thanks for your kind attention and passionate listening. Happy learning.